Well, howdy there, Internet students. This is Mr. Hermanson again. Hey, if you're watching this, then you want to retake your 4.2a objective. You didn't do so well on that, so you probably want to make sure you learned it. All right, so um, do this practice. Take notes, and when you're done with this practice, you can send it off to me. Attach it to an email, and I'll check it in. If it looks good, I'll get that retake to you. So this is all about exponential relationships. Make sure you're taking notes as we go so I can see the notes that and make sure you watch the video. So Mr. Williams brought 10 mosquitoes in their laboratory. He's told his students the population would increase by 3 times every month. Okay, so that means we're multiplying by 3. So which of these tables is correctly showing these areas? And you want the one that multiplies by 3 each time. So I think it's this one. John had the correct area. Okay, and the expression for that, since we're multiplying by 3, would be 10 times 3, and then the x tells us how many times. This expression would actually be linear and is adding 3 every time. I don't know why Nancy decided to add 20 every time, but maybe she saw the first 2 in John's table and then thought that it was a linear relationship. So exponential growth looks like this. Expressions are a times b to the x, where the b is whatever you're multiplying by each time, and the a is what you're starting with. Okay, so we're going to look for tables that are exponential. In other words, they're multiplying. So what you're going to do is divide the numbers and see if it's going up by some factor. So do 12 divided by 4, which is 3. And if you do 36 divided by 12 and you get the same thing, then that's a multiplying table. And this one's multiplying by 3 every time. And so the expression you're going to write is whatever you start with. So this one starts at 4, and then times whatever you're multiplying by, and then to the x power. Okay, so you're going to circle the ones that are exponential, and if it's not exponential, like I'm going to find one here that is not exponential. Seems like on this one we're adding 40 every time. The way you write an expression for adding is you do whatever you start with. This would be 40 plus, and then whatever you're adding every time, which in this case is 40, and then it's times x. It's not x power. Okay, so that's a linear expression. All right, so go ahead and finish those up. The other types of problems that you need to be able to do is, so you're going to just take a look at how these table values were created. If it's a linear pattern like this, or a linear expression, then you're adding the same thing every time. So this one's adding 4 every time. If it's an exponential, then you're multiplying by something. So since it's got an x power, this one is multiplying by 4 each time. So you get from one value to the next in this row by multiplying the previous number by 4. Okay, so you can go ahead and fill in the next table. The last problem that I want to take a look at is how do you figure out what you're multiplying by? Now, when you see this word exponential, that tells you you're multiplying by something. The way you figure that out is you just go ahead and divide any number by the previous number in the table. So I'm going to do 18 divided by 10, which is 1.8, and then that's my multiplier. And so to continue and find the rest of the values in the table, I'm going to, I think, what did we start with? 10. We started with 10. I'll enter that, and then I multiplied by 1.8. And every time I press enter, I'll get the next value. So 32.4, 58.32. So since these are animals, we're going to round to the nearest whole animal. So I'm just multiplying by 1.8 to get the next number. And the way I found out that 1.8 is I divided these two. All right, so go ahead and finish those up, and when you're done with that, you can send me a nice copy of your work, and I'll check it out, and if it looks good, I'll get that retake test to you. Good luck with that.